Exercise 1.1, question number second. Differentiate the following with respect to x. And here is question number second. There are product of the two algebraic functions here, and we first of all denote this function with y. Therefore, we will write let y equals to this function. This whole terms is in terms of the x, the main function in terms of the x. So we differentiate with respect to x, and we have to find the dy by dx. So differentiate with respect to x. We write differentiate with respect to x. We take the derivative of y, dy by dx, and also we take the ddx of this term, 1 plus 4x raised to the power 5 and 3 plus x minus x square raised to the power 8. Here there are the product of the two algebraic functions, so we use the product rule. Our product rule is ddx of first function into second function, the first function into derivative of second, plus second function into derivative of first. This is our product rule. We apply here. First function means 1 plus 4x raised to the power 5 ddx of second means 3 plus x minus x square raised to the power 8, plus in product rule we use the plus sign, so plus second function is 3 plus x minus x square raised to the power 8 into ddx of 1 plus 4x raised to the power 5. Here this first term is as it is, 1 plus 4x raised to the power 5, and we have to differentiate this term, second term, that is 3 plus x minus x square raised to the power 8. We treat this term as x raised to the power n, x raised to the power n, and our formula for x raised to the power n is x raised to the power n equals to n into x raised to the power n minus 1. So we apply this formula here. Here x means this term 3 plus x minus x square, and n means 8. 8 into, so 8 into means n into 3 plus x minus x square raised to the power 8 minus 1 means 7. And here there is a term, in x. So we differentiate this term, this internal term with respect to x, 3 plus x minus x square. 3 plus x minus x square. This is our whole first term. This term is as it is, and we differentiate this term. After that, we write here second term as it is, raised to the power 8, and after that we differentiate the function 1 plus 4x raised to the power 5. Same here, we apply the same formula here, x raised to the power n. So 5 into 1 plus 4x raised to the power 4 and ddx of, because this term is in terms of x, this is not the x, in terms of x. So we differentiate this term with respect to x, 4x. Therefore we solve this function, this step 1 plus 4x raised to the power 5 into 8, 3 plus x minus x square raised to the power 7, and derivative of 3 plus x minus x square is derivative of constant term. We know that derivative of constant term is 0. So derivative of constant term is 0 plus ddx of x, derivative of x with respect to x is 1, and minus derivative of x square is 2x. Derivative of x square is 2x. After that, plus sign here, so put up plus sign, and write this term as it is, 3 plus x minus x square raised to the power 8. After that, 1 plus 4x raised to the power 4. Differentiate this term 1 plus 4x with respect to x. Derivative of constant term is 0. Derivative of constant term is 0. And derivative of 4x means 4. We know that derivative of 4x means 4. Derivative of 4 is 0. And derivative of 4x means 4. So we write this, arranging these all terms, we write 1 minus 2x, 1 plus 4x raised to the power 5 into 8, 3 plus x minus x square raised to the power 7 plus 5 4s are 20 and 1 plus 4x raised to the power 4, 3 plus x minus x square raised to the power 8 raised to the power. Question number 3rd. First of all, let us denote this function with y. Y equals to x upon under root 7 minus 3x. This is the rational function. This is our u and our v. We know that the quotient rule ddx of u upon v is v square v into ddx of u minus u into ddx of v. We apply this quotient rule here. First, this whole terms in terms of x, so differentiate with respect to x. If we differentiate y with respect to x, then we get dy by dx and here ddx of 7 minus 3x. So we apply product rule u upon v, that is v square means under root 7 minus 3x bracket square. This v under root, here there is v into, means v is our v, 7 minus 3x under root 7 minus 3x as it is into ddx of u means x minus minus u means x and ddx of 7 minus 3x, ddx of 7 minus 3x. Let us check v square, v into ddx of u minus u into ddx of v. So this term is as it is, 7 minus 3x as it is. Derivative of x with respect to x is 1 into 1 minus sign as it is x, and derivative of under root 7 minus 3x. We know that ddx of under root x 1 upon 2 under root x. Our formula is ddx of under root x is 1 upon 2 root x. But here there is a terms in x. Here there is not x, is a terms in x. So we differentiate the x with respect to this term 7 minus 3x. So derivative of under root x means 1 upon 2 root x. X means 7 minus 3x into ddx of 7 minus 3x, 7 minus 3x, ddx of 7 minus 3x upon under root square, that is under root x bracket square equals to x. Under root x bracket square equals to x. So here under root x bracket square means x or minus 3x, 7 minus 3x. This term is as it is 7 minus 3x minus x upon 2 under root 7 minus 3x into ddx of 7 minus 3x. Derivative of 7 is 0 and derivative of minus 3x means minus 3, only minus 3. Derivative of minus 3x means minus 3 and upon 7 minus 3x. 7 minus 3x. So we write this after arranging the terms. We get this minus 3 minus minus plus here. So we write 7 minus 3x minus minus plus 3x upon 2 under root 7 minus 3x, 2 under root 7 minus 3x upon 7 minus 3x upon 7 minus 3x. Here numerator is cross multiplication term, so we cross multiply here in the numerator. We get 2 into this under root term 7 minus 3x. This root term is multiplied with the root term means under root x into under root x equals to x. Under root x into under root x means x. So here if under root 7 minus 3x is multiplied with 7 minus 3x, we get only 7 minus 3x. We get only 7 minus 3x. This denominator is multiplied with the term. We get 7 minus 3x, 7 minus 3x plus 3x upon 2 into under root 7 minus 3x. 2 into under root 7 minus 3x. And denominator is minus 7 minus 3x. After arranging the terms, we get 2 into 7 minus 3x plus 3x upon these terms in the numerator in the denominator of the numerator. So we put these terms in the denominator. So 2 into under root 7 minus 3x, 7 minus 3x into 7 minus 3x into 7 minus 3x. After multiplying 2 to this bracket, we get 14 minus 6x plus 3x upon 2 into under root. We write these under root terms as x to the power 1 by 2. And here there is a term 7 minus 3x minus 3x minus 6x plus 3x means minus 3x and 2 7 minus 3x raised to the power 1 by 2 plus 1. 1 by 2 plus 1 means 3 by 2 here. Therefore, this is our answer, dy by dx. Note it down. Question number 4. Under root cos of x plus under root cos of root x. This is the addition of two functions. So let us denote this function with y. Let y equals to under root cos of x plus under root cos of root x. Here the total term or this function, total function is in terms of x. So differentiate with respect to x. we get, if we differentiate y with respect to x, then we get dy by dx, and here the differentiation of root x. We know that the differentiation of root x is 1 upon 2 root x, and here our x is cos x. So root cos of x, differentiation of root cos of x is 1 upon 2 root cos of x, and this term in terms of x. So differentiate this cos x, again this cos x with respect to x, plus also here differentiation of root x, our x is cos of root x, so 2 root cos of root x, and ddx of is cos of root x. ddx of cos x is minus sin x upon 2 under root cos of x plus 1 upon 2 under root cos of root x as it is, and derivative of cos x is minus sine of root x, minus sine of root x. Derivative of cos x means minus sine x, but here there is a terms in x, so ddx of this root x minus sine, this term, first term is as it is, cos of x, this minus plus minus, and sine of root x upon 2 under root cos of root x, and this derivative of root x is 1 upon 2 root x, 1 upon 2 root x, minus sine of x upon 2 under root cos of x, minus this 2 into 2 to the 4, therefore sine of under root x upon 4 under root x into cos of root x. This is our final answer, dy by dx.